Hello dear student, myself Prof. Sukhbir HK. Today we learn new chapter thermal property of a matters. In this chapter we can discuss various phenomena are related to the heat or temperatures. Hence this property is called as thermal properties. Firstly, in this chapter we can discuss what is meant by thermal expansion. See here definition. Thermal expansion: the tendency of matter to change its volume with respect to its temperature is called thermal expansion. The tendency of matter to change its volume with respect to its temperature is called as a thermal expansion. Another definition, second one is a thermal energy. Thermal energy means what? The sum of all energy of molecule in a body is called thermal energy or internal energy. We can adding all energy. This all energy is called as a thermal energy or internal energies. Next definition is a coefficient of a thermal expansion. Coefficient of a thermal expansion. Simple definition here: the ratio of change in original dimension to the original dimension per degree Celsius is called as a coefficient of a thermal expansion of a metal. Uh, Here no, coefficient of thermal expansion means the we take here ratio of change in original dimension to the original dimension per degree Celsius. This thermal expansion can be classified on the basis of change in length, area and volume. Here we discuss new topics, type of a thermal expansion. Thermal expansion can be classified on the basis of change in length, area and volume. First type is a linear expansion. Linear expansion. See here definition: when body is heated, its length increases, is called as a linear expansion. When body is heated, its length is increases, is called as a linear expansion. Here mathematically we can write here, in increased length of a rod is directly proportional to first its original length and second one rise in a temperature. Then we can write mathematically, its original length increase in length of a rod. Here increase in a length of rods, here L sub t minus L0 directly proportional to the L0 into T. Here L sub t minus L0, remove this proportionality sign, we using some constant, that is alpha into L0 into T, where alpha is called as a proportionality constant called as a coefficient of a linear expansion. Then we calculate coefficient of a linear expansion. Then here alpha is equal to L sub t minus L0 upon L0. Alpha is equal to L sub t minus L0 upon L0 into T. Here L sub t minus L0 means increase in length per okay. Here L sub t minus L0 upon L0 into T. Then we can derive definition from this mathematical formula. Coefficient of linear expansion, this coefficient of linear expansion denoted by alpha. Definition: coefficient of linear expansion of a solid is defined as increase in length per unit original length at a 0 degree Celsius per degree rise in the temperature. Then we can write here linear coefficient of linear expansion. Alpha is equal to L suffix t minus L0 upon L0 into t. Second one, we can write unit of coefficient of a linear expansion. Here units of coefficient of linear expansion, this is a per degree Celsius, or we can write here per degree Kelvins. Note, it is depend upon nature of material. Then second type is aerial or superficial expansion. Second type, aerial or superficial expansion. Definition: when metal plates is heated, its surface area increases. This is called aerial or superficial expansion. Here we can write in increase area in metal plate is directly proportional to first original area. This original area we consider here A0. Second one, rise in temperature. Suppose rise in temperature we consider here small t. Mathematically we can write this A suffix t minus A0 is directly proportional to A0, and second one, A suffix t minus A0 directly proportional to t. We combine these two equation, we can write this A suffix t minus A0 directly proportional to A0 into t. Remove this proportionality sign, we can write this equation A suffix t minus A0 is equal to beta into A0 into t. Here beta, proportionality constant, is called as a coefficient of a aerial expansion. Then we calculate aerial expansion. Here beta is equal to A suffix t minus A0 upon A0 into t. Then we define what do you mean by coefficient of aerial expansion. See here a definition of aerial expansion. Coefficient of aerial expansion of a solid is defined as increase in area per unit original area at 0 degree Celsius per degree rise in temperature. Then formula of a coefficient of aerial expansion, this become beta is equal to A suffix t minus A0 upon A0 into t. Then we write unit of a coefficient of a aerial expansion. Here per degree Celsius or per degree Kelvins. Note here, it depend upon material of a solids. Coefficient of a aerial expansion depend upon material of a solid. Second notes, beta is equal to A2 minus A1 upon A1 into T2 minus T1. Another one, coefficient of a linear expansion, L2 minus L1 upon L1 into T2 minus T1. We can derive here relation between coefficient of a linear expansion, coefficient of a aerial expansion, coefficient of a cubical expansion. We derive a relation between these three coefficients. Here alpha is equal to beta by 2 is equal to gamma by 2. This is a relation between coefficient of linear expansion, coefficient of a aerial expansion, and coefficient of a cubical expansion or of volume expansion. Third type is a volume expansion. This volume expansion, it is also called as a cubical expansion. And definition here, when body is heated, its volume increases. This is called as a volume expansion. Mathematically we can write here, in increase in volume is directly proportional to first its original volume. With this original volume we consider V0, and a second one, rise in temperature, we consider T0. We can write this mathematically, V suffix t minus V0 directly proportional to V0 into t. That is, we remove this proportionality sign here. v suffix t minus v suffix 0 is equal to gamma into gamma into v0 into t, where gamma is called as a proportionality constant, called as a coefficient of a volume expansion. Then coefficient of a volume expansion we can calculate gamma is equal to v suffix t minus v0 upon v0 into t. We can derive definition of a coefficient of a cubical expansion gamma. Definition of cubical expansion: coefficient of cubical expansion of a solid is defined as increase in a volume per unit original volume at a 0 degree Celsius per degree rise in temperature. Then formula: gamma is equal to v suffix t minus v0 upon v0 into t. Then we write units of coefficient of a volume expansion. This become per degree Celsius or per degree Kelvin. Note, first note, it depend upon the nature of the materials. And next note we can write here another mathematical form of a coefficient of a cubical or a volume expansion. This become gamma is equal to v2 minus v1 upon v1 into t2 minus t2. In this way we can discuss three type of a thermal expansion. First one is a linear expansion. In linear expansion, when body is heated, its length increases, hence it is called as a linear expansion. Another type is a aerial expansion. When metal plate is heated, its surface area increases. This is called aerial or superficial expansion. And third one is a volume expansion. When body is heated, its volume increases. This is called as a volume expansion. And then we can derive, or we can discuss three coefficient. First is a first is a linear coefficient of a linear expansion. Another one is a coefficient of a aerial expansion, and last one is a coefficient of a volume expansion. This relation between these three coefficient is alpha is equal to beta by 2 is equal to gamma by 3. This is a relation between alpha, beta and gamma. And next topic we can discuss different mode of a heat transfer. There are three different mode of heat transfer. First one is a conduction, another one is a convection, and third one is a radiation. Firstly we discuss what I mean by conduction. The process in which heat is transferred from hot end to cold end without actual migration of a molecule or atom of medium is called as a conduction. In this process, heat transfer from hot end to cold end, that time the molecule and atom without actual migration migration of molecule or atoms. Conduction, it is a slow process. It require material medium. This process possess only solids. For conduction of a heat take place from one point to the another point, following condition must be satisfied. First condition is 2 point should be different temperature, and second condition, there should be material medium between 2 points. When this condition satisfied, that time heat to be take place from one point to the another point. Another type is a convention. What do I mean by convention? Definition. Convention definition: the process in which uh, heat is transferred from hot end to cold end. Their actual migration of a molecule or atom of medium is called as a convention. As compared to conduction process, convention is a rapid process. Second one is it is require material medium. The third one, transfer of heat through liquids and gases take place by the process of convention, and convention is not possible in a solids. And third very important mode of a transfer of a heat is a radiation. What is mean by radiation? Definition: the process of heat, the process of transfer of heat in the form of electromagnetic wave for which material medium is not necessary. This mode is called as a radiation. As compared to conduction and compare, this is a fastest mode of a heat transfer. Second one is a radiation take place in the form of electromagnetic wave, and third one, the it does not need material medium for their propagation. For example, sun and earth, there is a vacuum. In this way we can discuss different mode of a heat transfer. Some question asked on this topic: explain different mode of a heat transfer. Explain a different mode of a heat transfer. In this way we complete two very important topics. First one, we discuss different type of a thermal expansion, and second one we discuss different mode of a transfer of a heat. Then we discuss what I mean by heat. Definition of a heat: it is a energy transfer from a body hot end to cold end is called as a heat. Heat, it is a energy transfer from body hot end to cold end is called as a heat. Unit of heat is joule or calories. Then we can discuss another definition. What I mean by temperature? Definition: the quantitative measurement of a degree of hotness or coldness of a body is called as a temperature. Another definition: what I mean by 1 calorie? Definition here: 1 calories is the amount of heat that must be transferred 1 gram 1 gram here uh, 1 calorie is the amount of a heat that must be transferred 1 kg of temperature to rise its temperature through from 40.6 degrees Celsius to rise 14.5 degrees Celsius to 15.5 degrees Celsius. The the relation: 1 calories is equal to 4.186 joule, and 1 joule is equal to 0.2395 calorie. Then another definition we can discuss here: coefficient of a thermal conductivity. Definition here: the coefficient of thermal conductivity can also define as the quantity of the heat conducted in the steady state through a material per unit time, per unit area, per unit temperature gradients. The mathematically coefficient of thermal conductivity denoted by K. K is equal to first Q into L upon A into Q1 minus Q2 into T. Here d theta upon dt is equal to Q1 minus Q2. Units of units of coefficient of a thermal conductivity. This become joule per meter joule per meter. So here meters kelvins, and another unit is kilocalorie per meter seconds kelvins, and dimension here L raised to 1, M raised to 1, T raised to minus 3, K raised to 1. Another definition is a latent heat. Definition: latent heat of a substance is the quantity of heat required to change the state of unit mass of a substance without changing its temperature. SI unit is joule per kg. Another definition is a specific heat capacity. Specific heat capacity denoted by C. Definition: specific heat of a substance is defined as the quantity of heat required to rise the temperature of unit mass of a substance through the 1 degree Celsius or 1 kelvins. Formula: C is equal to Q upon M into delta T. Here C is the specific heat, M be the mass of substance, delta T be the change temperature, and Q be the amount of heats. SI units of specific heat is joule per kilogram per degree Celsius. CGS unit calorie per gram per kelvins. Another concept is a Boyle's law. Definition here statements of a Boyle's law: at constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. Mathematically, Boyle's law we can write here: P inversely proportional to P at constant temperature, that is PV is equal to constant. This is a Boyle's law. Another law is a Charles law. Statement: at constant pressure, volume of a given mass of a gas directly proportional to its absolute temperature. Then mathematically we can write this V directly proportional to T. Then we consider another concepts, ideal gas. Firstly we discuss what I mean by ideal gas. Definition: a gas which obey all the gas law at all pressure and temperature is called ideal gas. Ideal gas equation we can derive in this way. Let's capital P, capital V and capital T be the pressure, volume and absolute temperature, and small n be the small n mole of the gas. By the gas law we will firstly discuss when P and capital T are constant, that time V is directly proportional to N. Another one, when N and T are constant, that time V inversely proportional to P. And another one, V when N and P are constant, that time V directly proportional to T. We combine all three law, that is V directly proportional to N into T and inversely proportional to P. Remove this proportionality sign. V is equal to R into N into T upon P, where R is a proportionality constant called as a universal gas constant. Then we can derive rearranging this equation, PV is equal to nRT. This is called as ideal gas equation. This is called as a ideal gas equation. We can calculate the value of a universal gas constant, that is R is equal to 8.314 joule per mole kelvins. Another concept is melting points. It is also called as the freezing points. and ice points. Okay, first definition, what do you mean by melting points? Definition: at a standard pressure, the temperature at which substance changes its state from solid to liquid is called as its melting points. At standard pressure, the temperature at which substance changes its state from solid to liquid is called as a melting points. Another definition is a what do you mean by boiling points? Definition: at standard pressure, the temperature at which substance changes its state from liquid to gas is called as a boiling points. And last definition is a triple point of a waters. Definition: the temperature and pressure at which the gas, liquid and solid state, a pure water, coexist in a equilibrium is called as a triple point of a waters. This is the best example uh, of a triple point of a water is a ice. And next one, what do you mean by good conductor? Definition: the substance which conduct heat easily are called as a good conductor. All metals are good conductors, for example, and aluminum, silver, etc. dot dots. And another one is the insulator. Definition: the substance which do not conduct heat easily are called as the insulator or bad conductor. For example, gas, wood papers, etc. etc. In this way, we discuss main concept in a thermal property of a matter. In this way, uh, we we complete all these points in the chapters. Today we stop here.